My name is Kim Bernard, and I live in Rockland, Maine, and I'm an artist, and I like to make work that is public, uses recycled materials, is interactive, which means you get to touch it, involves the community. I like to get people involved in making my work with me, and is kinetic, which means that it moves.
In 2016, I was an artist in residence at the University of New England in Biddeford, Maine. One of my projects was to create a clean ocean wave sculpture. The idea came about when I learned about the International Coastal Cleanup Day. A marine pollution class was planning to pick up ocean debris on local beaches. I caught them just in time and asked that instead of properly disposing of the trash after collecting it, that instead they give it to me for a sculptural installation. My work study students and I painted a trash bin with a wave on it. We placed it on the campus and encouraged students, friends, and strangers to pick up ocean debris and deposit the trash in the bin. The students were diligently collecting data on what we'd gathered. In total, 88 plastic bottles, 71 cans, 18 lobster trap pieces, 8 shoes, 7 glass bottles, 4 golf balls, 4 shotgun shells, 3 hats, 1 dog toy, 1 horseshoe, 1 plastic tarp, 1 pink kiddie pool, 1 scarf, 1 CD case, 1 portable scale, 1 iron pipe, 1 gift card, and lots of plastic bags, food wrappers, fish line, and nets. We then hung a loom of stainless steel wire on the Marine Science Center lobby stair rails. For 3 days, we engaged the UNE community in a big trash weaving effort. UNE students, staff, faculty, and even some of my friends and family participated. The goal of the project was to engage the university community and raise awareness about just how much ocean debris washes up on our shores and how vitally important it is for us all to keep our oceans clean. The Clean Ocean Wave sculpture is now on permanent display at the Marine Science Center at the University of New England. Another project I initiated at the University of New England was to work with students to design an amphibious tiny house. There are plenty of tiny houses around, but what was unique about our tiny house was that it was to be amphibious, like a duck who lives on land and water. The Amphibious Tiny House team was a collaborative group of students, faculty, and staff who, just for fun, designed a see-through bottom tiny house that could float, be trailered, or parked anywhere. Our collaborative team met weekly, and together we brainstormed ideas and in true think tank style, divided and conquered by breaking into smaller teams based on interests, abilities, and skills. This multidisciplinary project required input from about as wide a range of departments as one could imagine. Students from all departments were encouraged to participate in this project, especially marine science, ocean studies, aquaculture and aquarium science, environmental sciences, business and entrepreneurship, math, physics, animal behavior, boat building, creative writing, communications, education, social work, and of course, art and design. Our amphibious tiny house was designed to be completely off the grid to gather and store wind and solar power. We made decisions about the roof style, taking into consideration a pleasing design, aerodynamics, low cost, and the benefits of solar modules versus flexible solar membranes. We designed the footprint of our tiny house to be 8 feet by 16 feet, with an overall length of the pontoons to be 24 feet long. Considering the limited volume, every square inch was to be utilized most efficiently, be multifunctional, and of course, be well designed and aesthetically pleasing. Other guiding and limiting factors to consider were building codes, harbor restrictions, vehicle size restrictions, DMV requirements like lights and blinkers, the availability, sustainability, and costs of our building materials. With the choice of a composting toilet, which the Environmental Club adopted as their project, we would avoid needing a holding tank or pump out. The aquarium science class took on the ambitious project of developing aquaponics, where we could grow leafy greens like kale, Swiss chard, and arugula in water. The Amphibious tiny house was always meant to be low budget, affordable, and mass producible. Having received funding from the Ellis Beauregard Foundation, our team built the Amphibious tiny house. Ultimately, we donated our Amphibious tiny house to the College of the Atlantic, where they use her as a floating guest house. All of our R&D, material list, and building instructions were fully documented and are available on our website so anyone is able to see or use our designs, supply lists, and instructions for free. Have a look at www.amphibioustinyhouse.org. Here's a project I created last year called Bring Your Own Bag. Do you remember the movie The Graduate, where Mr. McGuire says to Ben, "I just want to say one word to you, just one word. Are you listening?" Plastics. There's a great future in plastics. Think about it. Will you think about it? In the 1960s, plastics were just becoming popular, even though this novel material made of petroleum had been around since 1907. Plastics are incredibly versatile and allow us to store things easily and cheaply. But plastic is bad for the environment. Next year, 300 million tons of plastic will be produced worldwide. Every year, the average American throws away 105 pounds of plastic. That includes 35 billion plastic bottles and 100 billion plastic bags. Only 5% of the world's plastic is recycled. Virtually every piece of plastic ever made still exists. The good news is that over time, sunlight breaks plastic down into smaller bits. The bad news is that these plastic particles are then eaten by wildlife, which can kill them, get into our food, our water, and into us. Plastic is a substance our Earth cannot digest, and neither can we. Last year, the issue of banning single-use plastic bags came up with our City Council in Rockland, Maine. As a resident and a huge supporter, I showed up to support the plastic bag ban. I'm happy to say that our town passed a ban on single-use plastic bags. Right about the same time, I thought, wouldn't it be cool to do a sculptural installation at the Rockland Public Library to celebrate the bag ban passing? I got a thumbs up from the library, then wrote a project grant through the Maine Arts Commission. I searched the web to find just the right style bag, the right color palette, the right material, at the right price, and made a deal with the company to purchase in bulk at less than wholesale. Then I was awarded a grant to buy 300 high-quality ripstop nylon reusable shopping bags. The bag showed up on my doorstep, all rolled up in these compact, easy-to-ship potato-sized balls that fit nicely into your pocket or purse. After my students and I tried to learn how to juggle, played hacky sack, and toss with them, I got down to the business of opening them all up, tumbling them in the dryer to de-wrinkle them, color sorted them, stacked them, all the while thinking about how I was going to hang them at the library. After the installation of the 300 nylon bags hung in the library for 3 months, I dismantled the installation, then invited the public to come into the library and take away 1 bag each for free. Trash. It's such a problem. What can we do? Recycling is not the only solution. We can refuse disposable plastic, bring reusable items with us, purchase projects in sustainable packaging, bring our own to-go container or doggy bag, pack a lunch, and bring a spork, and help make hankies cool again. Consider buying a bamboo toothbrush instead of a plastic one. Bring our own water jug instead of buying bottled water. Bring a travel mug into a cafe instead of using a disposable cup. Say no thanks to plastic straws. Keep a cloth towel handy instead of using paper towels. And if nothing else, take the pledge to, from now on, bring your reusable shopping bags into the store. Our environment is one of the most critical global issues we all face today. If we don't address climate change, global warming, our increasing carbon footprint, overconsumption, and the depletion of natural resources, we'll all suffer the consequences. Waste reduction and disposal are issues that we can all address locally by reducing our consumption of goods made from raw materials and committing to recycling whenever possible. For years now, I've struggled with the dilemma of using raw materials to make art and feeling hypocritical that I advocate to reduce, reuse, recycle, yet use those very same raw materials in my creative work. For the last several years, I've begun using recycled materials, ocean debris, bicycle inner tubes, bowling balls, and reusable nylon bags, for example. This accounts for a fraction of my work, but my goal is to have 100% of my sculptural work be created out of recycled materials, ideally out of a material that can be shaped and molded and is durable, upcycled plastic. I'm currently building a portable upcycling machine for plastic. In researching plastic recycling machine designs, I found preciousplastic.com, an online open source with blueprints, CAD designs to follow and adapt if necessary, and helpful information about assembly. The plastic upcycling machine will have 4 components: a shredding machine, an injection machine, a compression machine, and an extrusion machine. All 4 machines will be compact and portable, allowing me to create at schools, art centers, communities, institutions, and museums. After being encouraged to collect plastic, deposit their plastic waste into one end, and a new malleable plastic will emerge from the other end. I will then, with the participation of the local community, use the newly upcycled plastic to create an on-site sculptural installation. I'm excited to see all the different ways that I can coil build and extrude plastic, create molds to fill with plastic, and 3D print with the extruded plastic coils. One challenge in working with recycled materials is that it often looks like the junk that it is. My intention is for the upcycled plastic components to become sculptural installations that transcend their source, not look like recycled plastic, but instead be beautiful, inviting, and engaging. For this reason, the project of building a plastic upcycling machine is ideal.
Hey, thanks for watching. I really appreciate your interest in my work. I love it when art and science collide. If you're interested in getting involved in my portable upcycling machine for plastic project, you can help out by collecting plastic. I especially want clean, label-free, colorful plastic numbers 1 through 7. You can get in touch with me through my website or by emailing me at info@kimbernard.com.
I hope you'll follow this project and my future projects on my website at kimbernard.com and follow me on Facebook and Instagram.